All right, today we're going to tackle a really clever design pattern that is all about efficiency. It's called the flyweight, and it's the secret sauce that lets massive applications handle huge numbers of objects without, completely falling over.
I mean, really think about that for a second. You're running around in some huge open-world game, and you see a forest with literally millions of trees, or maybe a battlefield just swarming with bullets and explosions. If every single one of those things was its own heavy, unique object in memory, well, even the beefiest gaming PC would just give up. The solution isn't about more power. It's about being smarter with your data.
Okay, so let's dive into the problem itself. The whole issue really kicks in when you need to create a ton of very similar objects. If you don't have a smart strategy, you are just marching straight into a memory nightmare.
So this is kind of the naive way to do it, right? You need a tree, so you create a new tree object. And that object holds its position, sure, but it also holds the massive texture file for the bark, the super complex 3D model for the branches, all of it. Need another tree next to it? Well, you create another completely separate object that also holds a full copy of that exact same texture and model. It's like loading an entire font file for every single letter A on a page. You can see how this gets out of hand, and fast.
This forest analogy is just the perfect way to understand the solution. It's all about a fundamental shift in how you think about building things, and that's what makes this whole pattern click.
So look, if every single tree object has its own copy of the heavy stuff, the texture, the model, and you need a million of them, you are literally multiplying that heavy data a million times over. Your app's memory usage just explodes, performance grinds to a halt, and your users, they're left with a laggy, frustrating mess.
And here it is. This is the big aha moment. The solution is realizing that not all data is created equal. We can split an object's data, or its state, into two different kinds. First, you've got the intrinsic state. Think inside. This is the data that's constant and can be shared, like the tree model or its texture. It lives inside the shared object. Then you have the extrinsic state. Think external. This is the unique stuff, like each tree's specific coordinates or maybe a slight color variation. This data is handled outside the main shared object.
So with the flyweight pattern, we do something totally different. We create one single shared flyweight object that holds all that heavy, intrinsic data, the model and texture, just one time. That's it. Then the unique extrinsic data for each of those million trees, their specific coordinates, their color, that's all stored separately, and it only gets applied to that shared object when it's actually time to draw it on the screen.
And the result of this? It is absolutely staggering. By not duplicating all that bulky common data over and over again, the memory savings can be massive. Seriously, we're talking about potential reductions of 90% or even more. This is how you turn an impossible memory hog into something totally manageable.
So how does an application actually pull this off? It's not magic, even though it feels like it. It's a really clever piece of architecture. Let's take a look under the hood.
Okay, the absolute heart of this pattern is something called the flyweight factory. Its job is pretty simple. It's the gatekeeper for all of our shared objects. You never create these flyweight objects directly. Nope, you always go through the factory.
So here's the flow. When your code needs to draw a birch tree, it goes and asks the factory. The factory then checks its little pool of existing objects. Hey, have I already made the shared birch tree flyweight? If the answer is yes, it just hands back a reference to that one single object that already exists. But if it's the first time anyone has asked for a birch tree, the factory creates it, sticks it in the pool for next time, and then returns it. This is how it guarantees that for any given type of tree, only one shared object ever gets created.
So you've got these three key players working in harmony. You have the client, which is the part of your code that knows where all million trees are supposed to go. You've got the flyweight object, which holds the shared stuff for one type of tree. And then you have the flyweight factory, playing the middleman, making absolutely sure no duplicates are ever made.
Now, as powerful as this is, the flyweight pattern isn't a silver bullet. You can't just use it for everything. It's a specialized tool, and you have to understand the trade-offs to know when it's the right one for the job.
Okay, the core trade-off here is pretty clear. You save a ton of RAM, which is the main goal, right? But the price you pay for that is usually an increase in code complexity and sometimes a little more work for your CPU. Your code now has to do this little dance of looking up the flyweight and then passing in the external data every single time, which can be more CPU cycles than just having everything in one big object.
So here's your checklist. If your app needs a huge number of objects, if your memory usage is your #1 bottleneck, and this is the big one, if you can cleanly separate that shared data from the unique data, then yeah, the Flyweight pattern is probably going to be a fantastic fit for you. All right, we've covered the problem, the solution, and how it all works. So if you're going to remember just one thing from all of this, what should it be?
This is it. This is the entire philosophy boiled down to one simple sentence. The Flyweight pattern is all about finding what's common, sharing it like crazy, and only worrying about storing what is truly unique to each instance. It's just a powerful principle for writing lean and efficient code.
And that brings us to the final thought, really a question for you. Take a look at the applications you work on. Think about text editors with all their character formatting, spreadsheets with millions of cells, or any system with a boatload of similar elements. Where are you duplicating data without even thinking about it? You might just discover a whole forest of memory hogs just waiting to be optimized.